Limiting and excess reactants are essentially just describing which reactant runs out when you react to things, to ingredients in a reaction. So one of them always runs out, and that one is going to be the limiting reactant, and then the other one you have some left over of, and that's your excess reactant. And the important thing here, and the whole reason that we're concerned with this idea, is that the limiting reactant always determines the amount of product made. And so if we're interested in calculating how much product would be made from a reaction, we always need to know which reactant limits the reaction. So make sure that you've taken these notes, and we're going to go through an example. Okay, so go ahead and write down, or paraphrase if you want to, this example. So if we react 113 grams of aluminum with 279 grams of iron 3 oxide, which would be the limiting reactant, which is the excess? So first of all, we need a balanced equation. So this is going to be aluminum reacting with iron 3 oxide. So Al plus iron 3 oxide, so Fe2O3. And that's just going to be single replacement, right? So that's going to give us Al2O3 and iron. Okay? And so if we have to balance this, which it looks like we do, our oxygens are good, 3 on each side. So I'm just going to put a coefficient of 2 in front of iron and 2 in front of aluminum. Okay? So let's look at what we're being asked here. We're given two amounts. We have our 113 grams of aluminum, 279 grams of iron 3 oxide. So I'm just going to record those amounts right next to them in the equation. So 113 grams of aluminum, 279 of iron 3 oxide. Okay? And we want to know which one's the limiting reactant, which one's going to run out. The way you figure this out is you just basically pick one of those two amounts at random. It doesn't matter which one you pick. I usually just go with the first one. So in this case, 113 grams of aluminum. And what I'm going to do is convert that using stoichiometry to grams of the other one, the iron 3 oxide. Because what I want to know is that 279 grams enough? Or maybe it's too much, in which case that would be, the iron 3 oxide would be my excess. So go ahead and try that now. Convert 113 grams of aluminum all the way to grams of iron 3 oxide. Okay, so hopefully you got about 334 grams of iron 3 oxide. So why did we do that? How does that help us answer the question of which is the limiting and which is the excess? Well, what you just did in getting 334 grams of Fe2O3 is you figured out, okay, if I need to use up 113 grams of aluminum, how many grams of iron 3 oxide would I need to do that? And so this I'm going to label need. And then I'm going to compare that to the amount that I have. So in this case, I need about, 55 grams more than I have of that particular reactant, iron 3 oxide. So if I need more than I have, that is my limiting reactant. So I'm going to label Fe2O3, oops, it's a big marker, Lr, and that makes, by process of elimination, aluminum is my excess reactant. So then which one determines how much product I can make? Let's say I'm interested in knowing how many grams of iron I'm going to make in this situation. Would you use the 113 grams of aluminum to calculate that? Or would you use the 279 grams of iron 3 oxide? Okay, so hopefully you're saying that you would use the limiting reactant, the one that runs out determines when the reaction stops. So hopefully you said 279 grams of iron 3 oxide. And so let's go ahead and do that one. How many grams of iron would you expect to produce from this reaction? And once again, I've determined that the 279 grams of Fe2O3 is my limiting reactant. So I'm going to start with that. I'm going to go, I'm going to go from 279 grams Fe2O3 to grams of iron. Let's see if you can do that. Okay, so there we see, starting with 279 grams of Fe2O3, we convert to grams of Fe, which was our product that we were being asked about. How many grams of iron would you expect to produce? I get 195 grams of Fe. And if I had started with my excess reactant, if I had started with my 113 grams of aluminum and converted that to iron, I would have gotten a bigger number. But the problem with that is that bigger number wouldn't have been true. I wouldn't have actually produced that much because the reaction would have stopped before I used 113 grams of aluminum, because I would have run out of my limiting reactant, which is the Fe2O3.